Assalamu alaikum, everybody. Hello. This is me, George. I will go today with you to present something related to introduction of polymer injection. Let me share the screen, share, and open the slides. Okay. I hope it's clear. Okay. Okay. Now, I hope my voice is okay. Now let's start the session of about polymer EOR modeling by CMG. But today we'll speak about only the introduction part. Of course, there are 5 days course for details, for more details, specific part by part, and how to use CMG as application to model it. But today we can get also overall view about the polymer from theoretical point of view quickly, and then we go quickly also to apply CMG and be interesting to use this application. Okay, so our agenda today is related to first we will go to make an introduction to use polymer enhanced oil recovery. Then quickly also introduction about simulation of polymer EOR using CMG. This picture is easy to show for us. Let's zoom. What's the difference between water injection only and polymer injection? Because in our reservoirs, of course, almost all of reservoirs not homogeneous. So we found not good sweep efficiency. We will find streaks of water go from injector to producer through high permeable layers, or once to frag the formation, or quickly break through some layers. But if we control the mobility of this water, it's allow a good conformance of using this polymer to control the mobility of water. So allow a good sweep efficiency. Now, the question will be what does have a good polymer oil recovery means? This means the water sweep around 10% of the required volume from the reservoir. This is not good injectivity, not good project. This is done because two reasons. The first reason is related to heterogeneity, are present like larger fracture, high or low permeability zone. So different permeability layers or highly fracture streaks, it's allowed to different distribution of water injection through all vertical layers or through reservoirs, so leave some oil unswept. Also, if there are like direct connection between two wells in the area, so let's go and make a pen. Where is the pen? If this reservoir and this one injector, sorry, this is the producer, and this is the injector. So we inject from here. Sometimes because the direction of fracture, so the water comes through these between two wells like that, and we left a lot of oil not recover between this area. So this effect on the sweep efficiency using water injection only. So we use additives to this water to enhance the mobility, so controls the movement inside the reservoir. So high molecular weight and viscosity enhancing polymer is added to water of the water flooding project to decrease the mobility of the flood water and also improve the sweep efficiency. So if you go here, this is famous diagram for anybody working in enhanced oil recovery. If you have 4 single 5-spot pattern, so 4 injectors like that, and in the middle is the producer. So we inject and push the oil through the producer like that. The slugs, it's like a pre-flush to conditioning the reservoir and allow no quickly contamination with the salinity or something that affect on polymer properties. Then after that, the polymer will push the oil in this chart show a homogeneous distribution of oil movement. After that, there are like a fresh water to push the polymer to push the oil to the production, and finally driving water also to control the sweeping or enhance sweeping efficiency inside the reservoir. To determine the volume of slugs, polymer, and fresh water, and also for salinity, of course, to protect the polymer salinity and polymer properties, and driving fluid water. To determine these parameters, we need simulation, of course, to do that. So polymer is considered one of chemical method EOR, chemical EOR, including alkaline, surfactant, emulsion, micellar, alkaline, surfactant, polymer. But polymer is a famous one, and through my experience, I found polymer injection is most popular than to use the other. And maybe because it's easy to understand, because we only control oil, water, so easy to design this project. Of course, many years of experience. So we have a good experience in polymer injection. Polymer water flooding is generally applied again when the water flood mobility ratio is high, so water move quickly faster than the oil. So we need to control this water mobility. So we add a high viscous issue like polymer, or we have a heterogeneous reservoir. So the distribution of water inside the reservoir is not good, so affect on a sweep efficiency. This is published data from the reference. I will show you the name of this reference. I don't know, you show this is a conversion of injectivity of Antonio Thomas, Dr. Antonio Thomas, published in October 23. It's like a review of polymer injection. So I use this as a reference to support my slides today. So this is the performance of primary production natural flow, or without any enhanced oil recovery, improved oil recovery. So this is the typical, black one is the typical performance for the production. It's around 80 months production, with this decline starting with around 15 or higher than 15 meter cube per day for oil. Then this field applied water flooding. You can find here the enhancement of production rate, oil production rate, of course, but with time, after 40 months, start to quickly decrease here, even with continue injection. Then polymer flooding starts after 80 months from starting of water flooding, some enhancement, of course, of oil, and less decline rates. Dr. Antonio, which has more than 20 years experience, shows this curve also as very important curve for injection rate, water injection rate. So, and make observations that the injectivity after water flooding, if increasing in the first period, then decreasing. So he asked a good question. What is interesting is how much injectivity decrease is observed when switching from water to polymer. It's like a combination of increased sweep and also resistance inside the reservoir. Why I chose this curve at the beginning, even I need to go for a simulation using CMG, but before we go simulation should be even, especially for polymer enhanced recovery, to understand what happened inside the reservoir before we go and make this modeling. So the first thing we should be review before we go to modeling, before in any polymer enhanced recovery, to review the injectivity, and comparing to the production, and try to understand from this curve, even sweep efficiency, good sweep efficiency with increasing of oil recovery, or just we lose this polymer inside the reservoir. But this curve, it's needed another parameter. This is the injection rate only. We need also the pressure. I will go for this point, but let me ask the main question come to our mind when we design the polymer injection project. The first question is the injection of any polymer solution even visible for this reservoir? We need to answer for that. Maybe we need to change the parameter of polymer. Maybe it's not economic. Maybe the parameter of our fluid, of our permeability, it's not, or depth of reservoir, it's not suitable to inject the polymer. So we need to answer for that. And the simulation model can support us for a lot of questions to answer for this question. Again, other question is how much might we lose? Yes, even the polymer will, there is no highly permeable stress. Even we inject the polymer in the good location, but still there are some adsorption of this polymer to the rock. So we lose some quantity of polymer on the rock. So we need to evaluate it to get the answer while designing the project. And the simulation, of course, support us to answer for this question with lab experimental, of course. Other issue is how rapidly can change the polymer and the effect of the polymer. How many time need to bring back the money of the project, this project, and also with times there are a lifetime of the polymer, with times there are degradation. So there are like a lifetime we need to take in our consideration to answer for designing of polymer injection. The last question will be, the last important question will be how to obtain the injectivity value without the frags formation. So every time we need to enhance the injectivity, of course, but we don't need to frag the formation, because sometimes once we frag the formation, we reach to something like that, high stress perm. So we need to enhance the permeability to allow the polymer come easily to sweep inside the reservoir, but in parallel, we need don't frag the formation. So using a high viscous polymer, we need to check the injection rate. This is the design rate, and also the pressure at each time step to define if we frag the formation, if we enhance the injectivity, so affect positive or negative on the project. So using investigation of collected data from the field with the softwares, available software, allow us to answer for this question? I think there are questions here. I don't know. Okay, I don't know. Let me finish and I will answer what certification. Okay. Okay. So to simplify the meaning of injectivity of fracture, maybe we frag the formation more. We should be go for a simple equation using for Newtonian fluid is injectivity index for Newtonian fluid. So for injectivity index, this is a simple equation, and viscosity here is constant. Constant meaning Newtonian fluid. If you speak about polymer, we speak about non-Newtonian fluid because the viscosity change with some parameter like shear stress or something, shear rates or something like that. So we need, if we deal with polymer, we will not deal with constant viscosity, we'll deal with curve of viscosity. But here, it's like just to understand what is the relationship between increasing the viscosity and the frag formation. So if we increase the viscosity of water here, the injectivity index will, of course, will be decreased. But this reflect to sometimes injection rate will be increased or the drawdown pressure or bottom hole pressure will be increased. With time, this pressure may be frag the formation. So should be find the optimum rate, the optimum value of viscosity to be increased to enhance the injectivity, not to frag the formation. Here, I mentioned here, this is the parameter per each equation, for this equation, and here, it is not this in this function, it's not adequate for describe injectivity for non-Newtonian fluid of polymer because it's depend on shear rates, so change from with time. So if we speak about polymer injection design, we speak about optimization process. Optimization process. Of course, for any EOR project, we speak about optimization process. I think any texture book, if you read a lot of book, you will find a lot or variants of difference. There is no fixed number. And this is related to optimization related to this field. So we need to study to answer about what is the optimized value, not what is the value. So the main categories need to be investigated, should be investigated before or after while manage of project of polymer flooding or simulation, of course. We need to investigate other parameters surrounds the history of polymer project. So we can categorize four parts. The first part is polymer related mechanism. What is the polymer properties itself? Molecular weight, rheology of viscosity, of course, chemistry, degradation, drag reductions, all parameter, salinity, of course, effect on polymers, quantity or concentration of polymers. We need to investigate these parameters to define what is the parameter will be used after that inside the polymer, inside the simulation to calculate and to design the project of polymer injection. Category 2 is related to polymer preparation and surface related mechanism. This category may be not used at all in a simulation, but should be make your QC because it's effect on the result of your simulation. So what is the equipment used to prepare the bond, the polymer solution? What is the hydration time? How to mix this polymer? So you need to make sure what is the properties of mixing of this polymer. We need to make sure from this part because affect on your design or your prediction if you use simulation. Maybe don't use this part in a simulation, directly simulation model, but it should be taken your mind. Other part is reservoir related mechanism. So we speak about polymer itself, polymer mixing and preparation, and now we'll ask about reservoir-related mechanism, especially near well flow regime, because in this area, near well bore, we have like a high shear rate, so affect on a viscosity of polymer, and we don't need to make a damage around the reservoir, and also conformance and this fracture and the high permeable layers and how distribute these polymer through all layers inside the injected well. Also, voidage replacement ratio relative to injection and production. If we lose a lot of polymer inside the reservoir or not. Heterogeneity. We need to understand, we need to investigate this parameter related to reservoir to make sure from the design of polymer water flooding project. The final one is, of course, what we are concerned is reservoir simulation studies. What is the modeling assumption and data quality used to design the polymer water flood? So if we speak quickly about part by part, so polymer-related mechanism, we speak about the main important part is related to this curve, is the rheology curve of viscosity relative to shear rate. Usually it's measured at the laboratory. So polymer solution behave as a non-Newtonian fluid. Like I mentioned to you, it's not a constant viscosity used in a simulation, but it affect on different viscosity according to shear rates, which is calculated inside the simulation. So we're at a low shear rate, as the viscosity decrease here, but with as a shear rate increase, the viscosity starts to decrease. Of course, low shear rate, it's inside the reservoir. High shear rate is in near well bore. So up certain value, the shear rate, the viscosity will return to its original, not serious, it's like an original behavior, a Newtonian behavior with constant value, but at a certain value. And this value, to draw this curve, we need laboratory to define. This curve with this shape, low, high viscosity, Newtonian, power low, and Newtonian, is called thinning, shear thinning behavior. And like I mentioned to you, it can be observed both in lab, rheometer, or inside the. This curve, it's possible to account the viscosity change at a different shear rate, which it's occur at a surface installation or at a well, but it's not possible to predict the corresponding pressure to drop that be impact while calculation. This curve, once is done inside the lab, measure viscosity, but the pressure resistance due to formation itself, it's not captured here. It should be have another curve is called resistance factor, which capture all the parameter effect on delta B on this curve. So should be take the pressure while calculation the viscosity, but the first estimation will be used is the rheology curve like that from the laboratory. Shear thinning, when polymer injection is started, the viscosity of the solution change again with shear, and in the fraction pressure drop decreasing because of the drag reduction effect. The conclusion of this item is related to the viscosity will be used to simulate to predict the oil production after that. It's a very important term, and this viscosity effect of shear, calculated shear rate, and also affected with pressure. So the best guess to put in our model is uncertainty value, even it's measured in the lab, but it's need to have a look for that to control the prediction after that. Another properties here is shear thickening. Here, like I mentioned here, is often studied in laboratory since it could be greatly impact while mixing or polymer injection under matrix condition. So, however, it's uncertain whether injection really occur under pure matrix condition. So it's like opposite what we have. But generally, like I told you, this is the curve. It's a apparent viscosity with shear rate, high shear rate inside the well, nearby well. And then here is inside the reservoir. And all of these parameters measured by viscometer. Of course, this is a porous meter. So shear thickening, like I mentioned before, it appears that many injection processes are carried out under fracturing condition, especially when a vertical well development. Here, fracture, I'm not speaking about fracture, hydraulic fracture, but I speak about microfracture. So microfracture allow to reduce the delta P surround the well. So then the transmissibility for polymer flow from the well into the reservoir will be greatly improved. We need these microfracture. We don't go for hydraulic fracture, but we need microfractures around the wellbore to enhance transmissibility of polymer. As the shear rate decreases very rapidly away from the wellbore, the condition required for shear thickening, like that, and we reach to this value. But usually, this not occur for shear thickening may not occur in the field. It's need to study and affect also go to add the effect of resistance factor, delta B effect, not only this the value of viscosity like that. Other parameter affect on viscosity also, not only the rheology, but also the molecular weight. You can find here, this is the shear strength or velocity, and this is the resistance factor I mentioned to you. And here is different, the same viscosity, but with different molecular weight. So you will find here there are different curves due to different of molecular weight of polymer. Of course, these results come from core. So all of these parameters, which I speak the parameter to be used in designing of polymer flooding, you need to think about it. What is the polymer I be used? It's recommended from service company. Great. What is the properties? I will need to go to lab to the study and prepare this curve for simulation after that, and make sure there are still uncertainty, but this is the best guess. But it's effect on the result by the end of story. This parameter again, I speak about polymer, then I speak about polymer preparation or surface related mechanism, and this not go directly for our simulation studies, but or polymer design, but need to put in our mind maybe effect on the project performance, so or project injectivity. So we need to go and investigate water quality used for polymer injection, polymer preparation to minimize formation damage. Formation damage will be affect on injectivity and injection pressure and something like that, and delta B, of course. Enough hydration time is required to make sure that no fish eye are present which could hinder the injectivity. It's effect on injectivity, of course. Fish eyes meaning caused by poor dispersion during the mixing process. So commonly as a result of adding the product too fast. So we need to make sure from the program of preparation of polymer as a feed. Parameter also should be put in our mind while go for design polymer enhanced oil recovery project. It's reservoir related mechanism. Of course, good reservoir description is always required to make reliable assumption and the calculation. But in reality, a lot of challenges to do that. But we do our best in any project to bring the best conceptual models to start the model. A good understand what make a near well poor area. This is a very important area if you go for detailed study for enhancing your reservoir using polymer injection. So the most important aspect when attempt in polymer and injection forecast. Of course, I don't go, once I build the simulation model, I'm not go details for this specific part. But usually we studied it like a qualitative using analysis of available data, not inside simulation because it will take a long time. But we take in our mind this point to enhance the injectivity or create a damage around the well. So the first thing to check is, do I inject in the right zone there and not out of my reservoir? A lack of pressure build up might be related to injection in the aquifer or out of zone. So review the log, available logs, especially for injector, is very important to allow us to answer for that question before we go for a simulation itself. Some other important factors are listed detailed below, like fracture, geological uncertainty, and the voidage replacement ratio. Fracture. Again, this fracture, I will not speak about fracture. I speak about microfracture, which is needed in polymer injection. Is probably the main reason behind the good injectivity value. Good injectivity meaning that we enable to deliver this polymer more deep from the well pores, which allow more good sweep efficiency. So the existing of this fracture-like feature is especially true especially in consolidated formation. The injection under controlling fraction control. Again, we need to optimize between the microfrac and don't frac the formation. Will be beneficial for overall enhancing the polymer injection, since it can limit the singular pressure drop and therefore mechanical degradations around the pore or inside the reservoir. This curve show for us the injectivity relative to water, 1/100, and radius of polymer front. So we speak about 0.7, around 0.7 from the injection relative to water injection. To enhance this value, assuming there is no frac, to enhance this value, we need some microfracture. So this curve will be go up and enhance the injectivity through the reservoir. As an oil blank is mobilized, it's likely that the fracture growth or matrix dilution will accommodate the pressure buildup. Moreover, if shear thickening, do you remember shear thickening, which is related to viscosity? So we speak about pressure and we speak about viscosity. Okay, the pressure buildup will likely force the creation of a new passes, including this fresh fracture. The fracture creation requires energy. This energy will be competing with fluid leak-off inside the matrix, which needed to sweep the oil. So understanding the geomechanics near the well bore will be allow us to understand more about this point. Sure, again, we don't go to simulate this in our professional work, but I don't know, maybe in future will be needed some, but till this moment, 15 years experience, I am not go to simulate something like that. But we follow up, we manage it through our work during my career using some analysis of data, of injection data, pressure data, and log if available, tracer if available. We need to understand the area near the well bore. But we put in our mind, because in a simulation we try to think about the injectivity every time, and in application in the field we need to think about the injectivity every time. Moreover, since it is an evolving process, so it's needed a periodic adjustment. So it's not an design the first time of polymer injection, no, but it's any improved oil recovery project or enhanced oil recovery needs surveillance, need well reservoir management from time to time. So HAL plot, like I mentioned to you, to study the injectivity, and the microseismic is available, step rate test is available, are useful tool which can be combined to characterize the presence of this fracture, microfracture, which enhances the injectivity, or it's needed to enhance the injectivity. Of course, we can use this parameter inside the simulation model if you need it, for advanced studies. Another part after microfractures near well bore is geological uncertainty. And we speak about geological uncertainties, we speak about heterogeneous behavior, like large fracture or highly permeable zone. So existing of these need to think about the relation between injection pressure, injection rate, and this stress. If this feature do exist, so it will be observed, of course, through water flooding. And through water flooding, we found we inject a lot of water and no enhance of injectivity. In that case, perhaps we grossly overestimated of injection, and more likely the voidage remaining from the primary production. We don't sweep a lot of oil. We keep a lot of oil inside the reservoir. But once you start to inject polymer injected, and this fracture, it's enable don't make a big breakthrough for polymer, just passes for polymer. So a vertical sweep efficiency of effective well bore lengths are improved. So we don't speak about cave, we speak about fracture. So injectivity and the rate of polymer may be lower, but there are some pressure, to push this polymer. And of course, it will be allow displace the oil. So at this point, if we have a frac, maybe we don't follow up the fracture pressure, but it will be beneficial then we use water flood. This can be de-risky if we use a tracer. So allow the make analysis, careful analysis, and the communication between reservoir and response and wells over the year, if it's applicable or not. Other parameter also good to understand is the voidage replacement ratio. Voidage replacement ratio is meaning the ratio of reservoir barrel of injected fluid to reservoir barrels of produced fluid. So it's like a mass balance. So we speak about should be effect on a pressure. So if maybe we don't found increasing in a pressure behavior, it's like a mass balance in our mind. So if there are a fracture present, sometimes or the reservoir is depleted, So the building of this pressure is not can be observed, but the VRR can be observed at this point. So it's necessary to make sure from this balance to avoid the uncertainty of fingering or delay chemical breakthrough or lose a lot of money inside your reservoir. So as you can find here, I speak about different parameter, not go for a simulation, different parameter affect on the project itself. And put in your mind while you go for a simulation to design the project or to make a history match. So like I mentioned, let me go back, sorry. Like I mentioned here. Okay. Okay. Polymer related mechanism. So we need to collect the data about the polymer will be injected. We need be because it will be used as assumption, first assumption for modeling, and will be used and design, of course, of polymer injection. And we need to review the mixing of polymer, and we need to make some characterization for our reservoir about microfractures inside the reservoir using the health plot or something like that, or what if there are fracture. So pressure at this point not go to be a good monitor point, but void replacement ratio will be better to be used. Heterogeneous. If you have this in our mind, you have a conceptual model to go for a simulation at this point. But we have some concern about simulation. Even I will go use CMG, but we need to put some issue related to some uncertainty about the simulation. And now I don't speak about bad expectation, or I am not I don't like to speak about the model give you higher prediction. No. I speak about the model maybe give a lower prediction than expectation. So the question is, why is the injectivity often much better in reality than expected? It requires a step back to understand how the expectation were built. Usually it's via 3D model and simulation. When designing a business case to determine the oil recovery efficiency and to calculate the economic, we ask what are the main parameter inside this model. So now we can define the difference. Why there are difference between field cases, actual field cases, and prediction cases. Nevertheless, accurate prediction of polymer injection behavior continue to be challenged. Several reservoir simulation cases exist which use different input, more or less complex. Some of the problem are rheology curve instead of resistance factor. Sometimes we use viscosity only, but don't take in our concern the pressure effect. So it's effect on the prediction using simulation. Also, some engineer use a lot of keywords, even not important for polymer. So we search for this assumption to input in this data file to capture all parameters, but in reality, it took a long time to run and also sometimes affect on result. So should be go step by step and effect of this parameter on the polymer in behavior prediction and compare to the actual case. Use also non-Newtonian behavior is tricky, especially for shear thickening. Pressure effect directly of shear thickening. Poor understanding, I am here now, poor understanding and modeling of near well bore sometimes affect, especially if the model don't capture the fracture formation, if the model don't capture the viscous fingering, So we need to capture or to simulate it. Sometimes, not sometimes, a lot of time, we don't have log to understand that, but we try to we try to capture while history match or something like that. So other parameter also, all polymer solution properties affect on the result. Polymer models in a commercial reservoir simulation generally assume that the polymer component exists only in aqueous phase. Sometimes we have like a polymer in actual field. It's like a precipitation. Properties of that phase depend on the concentration of polymer and the salinity of water, as well as other variables such as pressure, temperature, and shear rate. Anyway, we have like a best guess. We have a like best guess from lab, from our available data, like any simulation model. But we should have in mind while history match or prediction, these parameters will affect on your result by the end of story. I'm not speak about defend about, I am not against about the simulation run results, but I speak about with engineers or designer of polymer enhanced oil recovery. So we need to put in our minds this parameter, of course, to enhance our work. The effect I will show for you some of parameter. It's related to rheology curve. So let's imagine the rheology curve. Usually in simulation, if you use sometimes using empirical methods to calculate the apparent viscosity, like you see here, it's a relationship. Apparent viscosity is the viscosity, and other plus other function, it's a function with non-Newtonian and shear stress, shear thickening, which is affected by shear rates. And shear rates calculating also affecting by average permeability in the cell and the porosity inside the cell, saturation inside the cell. Saturation usually calculated using simulation, and also shear rate also here, shear empirical coefficient and shear rate here you'll also calculated inside the simulation. So let's think about. We calculate shear rate, we calculate saturation, and its effect on apparent viscosity will viscosity by the end of story. So all of things affect on each other. So it's effect on result or effect on prediction. So shear rates, like I mentioned, it depends on the phase velocity, which calculated inside the simulation. And also it depends on great cell geometry, reservoir properties, flow rates. So sensitive to the model. So should be study that in a good point. Even we have a good lab data, but we need to take in our mind while history match, we'll need to make a sensitivity about that. Also, again, the microfraction inside the well pore, because a non-Newtonian effect appear greatly near the well pore. So where the flow rate increase. So here affect also in the viscosity near the well pore. We need to imagine the relationship between all of these parameters together. Sometime we need to create a radial grid to capture this effect. So to conclude this point, apparent viscosity is which is intuitive viscosity of a polymer solution may be different from the viscosity measured and the actual field results. So the parameter chosen simulation purpose should be derived from core flood, not as much as possible, not only from direct lab result. At this uncertainty value using the history match. Look here is like two curve with the same relative same of viscosity with shear rate, but it's different if you go to study using core and resistance factor. So resistance factor affect directly on the behavior of rheology. The good news, CMG have a good point and easy point to capture both rheology and also formation resistance factor effect on the viscosity. So we have a good tool to be used to support us for 1 minute. There are somebody admit. There are some people. Okay. Okay. Other issue is related to well model. Usually to capture, like again, the microfracture and the change near the well bore, which be connected also to non-Newtonian fluid, apparent viscosity. So usually we use adjacent skin factor while modeling because it's the only quickly tools to be used to capture it in the injector to be matched with the actual field result. So now I will go to CMG, but before I will go CMG, I like to give a brief conclusion what I present for you. So I speak about injectivity here. This curve, remember this curve, injectivity and the relationship between injectivity and the behavior of polymer. And we need to capture this injectivity and to analyze this injectivity of polymer and connect it to sweep efficiency. So to follow up this injectivity could capture even pressure or voidage replacement ratio. Of course, we characterize the reservoir, but we need to capture this part. To go for a simulation, we need to understand or categorize four important parts. And this part need optimization process. First, the polymer assumption, the polymer itself. The main curve is a rheology of viscosity because it's a non-Newtonian fluid. So viscosity changes with shear rates, which more and saturation, of course. And it's related to, we need to prepare this curve with sensitivity, with salinity, with molecular weight, because this data will be great effect when we predict the oil production. Also, if you are working in any project, you need to check the preparation of polymer, because if you don't have a good preparation, because the water water quality is not good or the preparation is not good, so affect on the performance of polymer. Maybe not captured in simulation, but need put in our mind. Also, here we speak about the near well bore regime and fracture heterogeneous voidage replacement ratio, which captures the injectivity and sweep efficiency, and put in our mind conceptual model before go for simulation. And finally, we speak about some parameter effect on the prediction, effect on the history match, and this parameter I hope to support you while we go for a history match. We don't have too much time, but I will go for CMG. And I will try to build with you quickly CMG case for to see the effect of polymer injection and how to use easily CMG to prepare your study for your manager, for your company, for your even for your university, to publish them with good result and with good software like CMG. CMG is a good software, like I mentioned. I think it's built more than in 1970 or something like that. It's built by university. So we speak about a good technical software. It's till this moment CMG connected to the universities. So once you have a good application, good publication in university, especially in Canada and the United States, bring this correlation and update their software. So we speak about a good, powerful tool to be used. From operational point of view, we speak about easy to work, easy to organize your project, easy to, it's not a complex, it's simple way to work on it and to learn it. Again, it's facilitate to organize the project file using a launcher of CMG. It's easy to navigate between project and manual using and running cases using your navigator. I will show for you, but let me go through slides and then I will go to software itself. CMG here is, I will speak three parts, a general screen description of this launcher once you open it. And if usually we create or add a project and start to create some cases inside this project. So how to create it, and documentation, which is great useful from in CMG once you install in your PC or your laptop. Once you open the launcher, you will find four parts here. The first part is related to this is through launcher. You don't need to go for filters. We'll open launcher and we'll navigate through launcher. So here is a folder you are working on. Here, what inside this folder? Here is the location of product of CMG. You have different product. Here is like information or running database. If you running is a case, it will be green. If completing, if waiting until finish is run. So we give you a status about the simulation, and also give you when submit this case, when it started, and when finished. Because sometimes we submit and wait like here, wait till finish this run to start running the case. From this bar you have here, you can filter, easy to filter. You select like a data file. I need to show only from this folder data file, or I need to show builder. I will go to builder, what's the meaning of builder, but anyway, results or whatever I need to show, I can select from here. All I can select all, I can show here all four files inside the folder. So like you see, I open launcher, then I control through launcher. I don't need to go for other folder to search for these, to copy and paste, through launcher only. This is the basic extension, .dat, like any simulation. It's including the data file of model, all information related to modeling. Include file, include .fhf, it's historical data, usually using for history match. .output is output file in ASCII text. .src is binary data related to CMG to used to like output for result for graphs, all things related to CMG. Again, here we can find the current folder, and here to move between folder, if I make zoom. So it's like up, search, refresh, and this is the location of your folder. This is inside the navigator, so launcher, CMG launcher. So we don't need again to go for outside the launcher to reorganize your machine or your desktop. You can make a copy and paste here, so it's easy to control. Here, if you find when you're running the case, it's green, which meaning is good. Sometimes it's fail. We need to be solved. It's like red, so it's a good option for visualization. To create and add and modify project, this is the power for that. You will find plus for add, and this is to modify the name of project, and this is if you need to delete the project. And here, for example, I select plus, and now I create directory when I need to save my project. And here, what is the name of this project? Then it's easy. So I'm not going to create a folder through launcher. I can use it. Documentation, because once you install the software, you need to be used. Sorry, I don't know. Okay, so I don't know the file. Oh. So documentation here, like I mentioned to you, this point, you can select to really to view or browse your documentation, which is stored once you install your project, your CMG inside on your laptop or PC. And this is the manual and also some tutorial to be used. What is the product of CMG? CMG have a different product starting from WinProp, its equation of state, and the BVT fluid characterization. And I believe it's good software, especially for EOR. If you speak about EOR, I support you to go to use WinProp, especially for thermal heavy oil. There are simple methods to create a complex equation or a valid equation of state with simple parameter. Then this is like a pre-processing built-in of the model. It's a builder, so it's collect of static, relative permeability, BVT, initialization, and also numerical control to run the case. Then we have different model, even to run using the black oil model or compositional model or thermal model. Once you select the model and run it, you can show the result at this application result post-processing. Finally, there are applications. Not how to move full screen. This is a CMOS post-processing, a status history match and optimization and uncertainty analysis. Even it's like it's like okay, it's like a individual application, but by the end, it can be used easily to build a professional project with sensitivity, with advanced application for optimization and assisted history match. Again, builder used to create the case, of course, and also for IMAX, GEM, and STAR, and also convert the case from IMAX to be compositional or thermal, or convert the case from E100, Eclipse 100 to IMAX black oil model. If you select the application, okay, if you select the application builder and start to create the project, you will select easy to select the model. What do you need? It's easy to use. I will select bottom here. What is the working unit? SI. I will select here. Porosity. I will select here. If it's single porosity or dual porosity or permeability. If a dual porosity, what is the shape factor? It's easy. And there are different applications. We don't know to go and remember what is the keyword and something like that. Using CMG, everything is smooth and simple. So it just be click. And starting of simulation model. Also easy to create a pattern for study because this is EOR. So we speak about pattern. So you just click here reservoir and using the reservoir quick pattern grid. And in quick pattern grid, you will select the type of pattern you need. Normal 5 spot like that, or inverted spot. What you need, what you need, and is even 5 spot. It's great to be used. So it's easy to build a pattern, and this is a very benefit for EOR project feasibility studies. After you create the pattern, you will ask you a simple question. What is the pattern acres? What is the thickness? What is the top of reservoir? What is the deep angle? I don't know what. Somebody need to talk? Okay. What is the grid block to make a blocking 4 meter by 6 meter, and then I will tell CMG calculate. He quickly calculates the path, the sector model to run your pattern. Now I speak about if you need to create a pattern for quickly feasibility study, but of course, CMG is a dynamic model, so we can load any geological model and try to build your model. It's same like any good application. It's a great application to be used for reservoir modeling, especially for EOR application and polymer EOR application. Then you need to make some alarm. We need to complete some parameter. So I will complete the permeability and compressibility also have an alarm. So he speak with you. I need to complete this parameter to be ready for run and something like that. So you complete. And then easy to define your fluid properties if you don't have equation of state. Just you give some parameter, small parameter, and he will initiate directly BVT. And here he will initiate relative probability. Here is like suggestion for equation. If you have a type of correlation need to be used for limestone, sandstone, or we don't have. So you need the endpoint, and it's easy to create relative permeability. And once you create a relative permeability, there are options for a high stress effect and also change weightability with time. So this is the more benefit, especially in a thermal and EOR project. Like I mentioned to you, it's easy to it's easy to create a BVT if you don't have any exist equation of state, and for a water also, and to generate BVT tables. Here, if you when you define the well, we define the location of well, and easy. As you can find here, I don't speak about the code. I don't speak about what I mean 2 or 4 steps. We just logic, ask yourself and select from the list. So it's easy to build the model and insert your parameter. If you compare for other for me. So if you compare with other software, this is the easiest one. Okay. Here, if you check the oil viscosity and it's not matched, for example, and you need to match this viscosity, there are a small parameter to shift because this is the numbers created by correlation. So shift the column value to match the viscosity, and at this pressure I have this value. So he shift um, the viscosity and to be matched with what we have in your lab data. So we speak about a powerful and wonderful tool. Even for polymer, we only select like a process wizard. It's a magic tool. And this polymer wizard, all of the parameters related to polymer, like polymer viscosity function of salinity, if you need to change the salinity, or reduction of SOR related to polymer viscoelastic behavior, or polymer quantity decreases with lifetime, degradation effect of the lifetime of polymer. It's easy just to select and enter the value from the lab or from analog studies and try to run. It's easy, more easier with software. Polymer is also absorption on the rock. It's easy to select. And this only using IMX tool. So if we speak about GEM and stars, we speak about also interaction function between polymer and other hydrocarbon or water. So especially water. So there are advanced tools to be used like interaction, chemical interaction between polymer and other fluids. Due to short time, I'm not go for details now for that, but I will quickly show for you if I open launcher. Okay, this is the launcher, and then I will go. Let me go up from here. So it's easy to go up. As this is the folder I will be select. It's easy to see what inside this folder. This is the webinar. This is the data set needed for webinar. This is the rescue file. To build your model if you need to build. Okay. This is the test data. So let me create, for example, I don't need that one. Okay. So I will create a project like here. So add a project. Then I browse for the location. I will go to, let me go here. Programs and simulation and CMG, for example, Polymer. Okay. And okay. Then I will create like polymer injection. Okay. Okay. Now I will open this case. It's a history matched case. I will open my builder. Okay. So this is a builder to build your case. You will find here the in and out control reservoir. If you go for reservoir, you'll find the grid, and this is how many blocks inside the grid. More information about the grid, or you can go here to show different views, 3D view or aerial or section like that, or other section. You can go from layers from here. It's easy. Okay. And here you can, if you have different dates, you can select. For example, if I will uh, check prosty, for example. Okay, and this is the drilling date. So if I select the final date, I will, it's easy to check. Here I can rotate my model. Here I can zoom. Okay. Even here you can 3D setting, for example, and let's select the transfer and apply. You'll find it's like this. So it's easy. I'm not make any right click properties and remove apply all. Okay, it's easy to check the location. And if I need to make an analysis for this property, so from tools, I can go to grid and to property statistics. So it's easy to go for average and 16% for volume, and the average is 16%. Again, if I go to permeability tools, it's easy to from here, it's easy to check statistics, grid and the property statistics, and the average is 200, 180 weighted. What is the weighted average? So this is a quickly analysis of grids. Also here, if you let me show for you. If you reservoir and go to for analysis properties, it's easy to check any parameter with any parameter. Here I selected directly porosity with permeability. So it's easy to check the relationship between if you need to check. We have another webinar using CMG. I present for it. Cannot understand French. Can you rewrite again the question with English? Thank you very much. Okay, so to build the model from scratch, if you have only maps and log and it's another webinar using the CMG thermal. It's related to thermal, but you can review it if you need it. But today, because the time is we don't have too much time, so I will go directly to what I need. So here is reservoir. This is the properties of reservoir. If you need to change any properties and it's green, all of them is green. If you have a red color, meaning you need to modify. But if you need to specify or something like that, you can come here and specify properties and select what we need. For example, permeability K is equal 1.5 from permeability in I, and J is equal permeability I. So we have different, if you go here, we have bench out from viscosity. We have small part from geological modeling. So, and this is the rock compressibility. This is the value of rock compressibility, reference pressure, and something like that. Okay. So this is the reservoir, and this is the BVT. What we have, if you need to, sorry, need to show the BVT. This is the parameter, and this is the BVT table. Okay. This is the RS. If you need to BG, E gas, or viscosity. Then this is the relative permeability curve. Okay, it's defined also, and this is the initial condition. It's defined the initial pressure. What is the datum pressure and what's oil water contact and the system water oil contact. It's like a select and write small numbers. It's not a big issue. And here the well, and inside the well you will find the date, and because we load the data, and so the date and the maximum pressure and maximum rate per each time step. Anyway, this is the matched model. We don't use any water flooding in this case, or any polymer. So I will save it, file, save as. Let me save, select here, and I will save it here, 1_1. Save, okay. Then I will close builder, save, yes. Okay, so I will go to select this case and run using the IMAX. So project name, like I mentioned, project injection. Here is the number of process according to your process in your laptop or your PC. This is if you need to run immediately with another server. No, I will run like here. So here mentioned to me waiting to start, and he will check. I have a question here. How change injection time? Okay. Let me. Okay, I will go for injection case now, but wait with me. Okay. Now this case is a normal case without any additional. Okay. Now if I go here, reopen. Now it's green, it's running. Okay. Now if I select the same case and let me save it again, I'll save as. But at this time, I will name it as prediction water _1. Okay. And I will try to create a 2 injector. Um, 1 minute. Water injection. Currently I will just show for you the work flow. So in a water injection, I will select 2 producer. Well 5, if I select here. Sorry. Did you see it here? Oh, and well 16 here. Okay, so I will create 2 wells. So I will go here, copy wells, here, all of wells, but I need to copy 5 and 16. So deselect, and I will select 5 and 16. Then next, copy all perforation dates, copy geometry, copy trajectory, and the same name with eng, and I will create dates 2010 at March, at January, March, let's see, March, 1st of March 2010. Next. Then he takes the same information like those wells of geometry and trajectory and create a new wells at this time. CMG is to facilitate the numerical issue. He create a new well like an injector, so a twin well. So once start injection, he shut in the producer and go to run uses the other well for injection, which is facilitated for numerically point of view. So I will create a finish. Of course, after he give me like a word, if I put right click and validate, he give me what is the constraint. It's constraint details. So I will select this well and double click. Okay, and from here I will deselect all from this filter and select these wells. Okay, so I will define the well like injector mob. Okay, and constraint. Did you apply the change? Yes. And the constraint, I will select here, operate maximum. It will be 20,000. Then click apply. Then fluid injected water, apply. Okay. Then click OK. The other well, okay. I can go to select, I can just mob. Then I can, yes. Then I can take, select from control and select. And from tools, I can copy event using filter. Then I select the name of well, date. Okay, fine, add a new date. 2010, March, 1st of March, okay. This is already existed, okay. So let's don't copy. Again, constraint, so here, constraint, rate, 20,000. Apply. Then injected fluid is water, okay. 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 Now we create the injection, but need to create to stop the producer. So I will go here and from here, and I will select this well and this well. Okay. Let's go for the last date. I hope to. It's okay. Let's select well by well. So here, this is 5. And so from here, I will go to option, status, shut in, apply. Okay, the other well, I will from here filter, select the other well, other producer, then go to the last date, option, shut in. So like you see me, it's like steps and easy steps. It's not need to write a complex data file. No, it's easy. Then, okay. So now this case is ready. Okay. There are other time polymer concentration. I will go to polymer now. Attendance link. It will be managed with OPA. 1 minute, it will be managed. Don't worry. Also certification, it will be managed. Okay. Let's go for CMG. The run for this tutorial is taken from less than 1 minute. Started, sorry, 3 minutes, around 3-4 minutes, something like that. Anyway, okay, I will speak about later about that one. Okay, so now we speak about IMX prediction base _1. This is the case. SR3 is a result. Now we create another case, water prediction 1. I will take it and use in IMX. again to run. So the process, okay, then I will click okay, waiting to start. I'd like to mention for you the more details because today we speak about introduction quickly, but the more details value is related to our courses, 5 days course, and we go step by step using different project, different data file. So I hope for you to launch for this course. Soon will be published by OBA about this course. So it's beneficial uh, to register for this course. Okay, I need to show for you something. If I close and open again. Okay. Look, here is how many percentage it's of running. Yeah. Okay. Let's create the base case again. No, wait. Let's create the water flooding case. Okay, it's already open. So file, save as, and created like a polymer. One, and okay. So this is the case. So if I need to create the polymer, it's easy. Just to go here, component, and the process wizard, like I mentioned to you, then select polymer. In a polymer, he give you some indication, some information. Injected polymer should be, what is the condition? The polymer flooding is less than 200 centipoise, and the minimum average per minute should be higher than 20 milliliters. Something to be like a guideline. Then next, and you select what we need. Today, I am not go for this option, but this is the polymer with salinity. If you need to change the salinity, it gives sets initial salinity, something like that. But today, I will just to see you. Here is like a new BVT structure. What is if you need to add shear velocity or shear stress or fast function of velocity, if you select, you will enter the data for that. If you don't have data, or function of shear stress, if you have, it's okay. If you don't have, for CMG, it's easy to build. And if you have different parameter, like I think if I go to here, polymer concentration, here is shear مثلا for Z parameter. I will don't know. Okay, next. Here, I'd like to absorption. مثلا. If you select absorption here, he will give you some parameter related to absorption. But again, today is just to see the application. And I will select the polymer injection quantity as a weight percentage. And then I will select the time. It's same time for injection. Then I will finish. He give me the message with the time and the concentration of the polymer. Then I click OK. Then the case is ready to be run now. To save, just go to reservoir and save. Okay, and it's easy to close. Yes. Okay. Yes. Okay. Still running. Okay. So I will go to polymer, select the polymer case. 1 minute. Okay, completed. Okay. It's around also around 4 minutes, I think. So I will run the last case, Polymer. Okay. Okay. Now, so today we speak about the uh, polymer, when we use this polymer, and the main important injective parameter is injectivity to be followed, to be monitored, and also optimization process related to what is the value of polymer, rheology curve, and resistance factor, and also what is the mechanism of polymer while preparation, and reservoir related mechanism, what is the fracture or not, voidage replacement ratio, and also some parameter effect on reservoir simulation studies. I will show for you. This is some data will be used. This is during the next course. This is like a theoretical general aspects for polymer. We go deeply for all parameters technically. It's a good point, and this is also examples to be used. We have one example with data file to be used during the course. We have different, and we'll be run using ZGEM and using also IMAX. So it's a good point to attend this course. In parallel, we have also how to use Builder in a professional way, and how to create the wells, and how to make a different tricky in a simulation using CMG. It's good course to be attend and good information, and I think so any other polymer course not cover this action from practical point of view. So it's a good time for you to connect to this course. Now I will open results until we finish this. This is the result post-processing data. Okay. Then this result, it's easy also to use. I open file. I go to the location of my save file. I will open SR3 base case. And I will open water SR3, one SR3. Okay. During the course also we'll go details for this, how to use this great application to create a dashboard or something like that. But here we create time series for two selected data file, two selected result, just daily oil. This is only for well, one well. So I will select sector, and I select two wells, two cases, entire field. Then here I will select oil. Then I will select oil rate standard condition. And then I will add a new plot. 7. Don't know. It's not defined. Why defined? It's okay. Maybe I'm not save this one, but I will. Maybe I'm not safe before running the change. I have one build before the tutorial, so I will remove this. Remove, and then I will add the same case, but the water. Maybe I'm not safe. I still open before I run. Okay, and then I will go to oil rates. Sorry, oil rates. Okay, where is Okay, so you'll find this is the base case and this is the effect of water injection. Let's check polymer steel 73. By the way, I can load the result while running, so I can go here and open a file and select polymer underscore one. Okay, so this is the three curves. Like you see, there are improvement of, I can change the polymer color easy from here. So, what's happened? Okay, types. Let's oil rate, standard condition. I don't know what's happened. So, okay, so what is source? Time series again. Vectors. Oil reduction. I have a new plot. So this is I will, change the color. Okay, it's easy to. We have update. We write here. So this is the incremental of polymer, and this is the incremental of water flow, and this is the end of base case. Okay, today I finished my webinar with quickly introduction about polymer enhanced oil recovery. I try to be get the reference from the new and also show for you the easy way how to use CMG to build your case. Okay, now we have like a form to be built for certification or something for attendees. So thank you for all. You will find in a chat. This form should be full. Feedback from you, please. Thank you for all, and I hope to register for the course, which will be next Saturday, most probably will be confirmed. Thank you very much. See you soon, and greeting from OPA. Bye bye.